Hi, hello there. Welcome to Etherchannel. Your network design includes redundant switches and links. You have some version of SDP configured to prevent layer 2 loops. But now, like most network administrators, you realize that you could use more bandwidth and redundancy in your network. Not to worry, Etherchannel is here to help. Etherchannel aggregates links between devices into bundles. These bundles include redundant links. SDP may block one of those links, but it will not block all of them. With Etherchannel, your network can have redundancy, loop prevention, and increased bandwidth. There are two protocols, PAGP or PAGP and LICP or LACP. This module explains them both and also shows you how to configure, verify, and troubleshoot them. Let's start. Okay, so on this video lecture, we will be talking about Etherchannel. At the end of this video, you should be able to troubleshoot Etherchannel on a switch link. Topics includes Etherchannel Operation. So at the end of this segment, you should be able to describe Etherchannel technology. Configure Etherchannel. You should be able to configure Etherchannel after this segment. And verify and troubleshoot Etherchannel. So you should be able to troubleshoot Etherchannel after this section. Etherchannel Operation. Link aggregation. So there are scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. So multiple links could be connected between devices to increase bandwidth. However, the spanning tree protocol or SDP, which is enabled on a layer 2 devices like Cisco switches, by default will block redundant links to prevent switching loops, as shown here in the figure. Okay? Now, a link aggregation technology is needed that allows redundant links between devices that will not be blocked by SDP. This technology is known as the Etherchannel. So Etherchannel is a link aggregation technology that groups multiple physical Ethernet links together into a single logical link. It is used to provide fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. Etherchannel technology makes it possible to combine the number of physical links between the switches to increase overall speed of a switch-to-switch communication. Etherchannel technology was originally developed by Cisco as a LAN switch-to-switch technique of grouping several fast Ethernet or gigabit Ethernet ports into one logical channel. When an Etherchannel is configured, the resulting virtual interface is called port channel. So the physical interfaces are bundled together into a port channel interface as shown here in the figure. So if you have seen this symbol here, okay, so this means that we have bundled these two physical interfaces here. And this forms an Etherchannel. Advantages of Etherchannel. Etherchannel technology has many advantages, including the following. So most configuration tasks can be done on the Etherchannel interface instead on each individual port, ensuring configuration consistency throughout the links. So Etherchannel relies on existing switch ports. There is no need to upgrade the link to a faster and more expensive connection to have more bandwidth. Load balancing takes place between links that are part of the same Etherchannel. So depending on the hardware platform, one or more load balancing methods can be implemented. These methods include source MAC to destination MAC load balancing or source IP to destination IP load balancing across the physical links. So EtherChannel creates an aggregation that is seen as one logical link. When several EtherChannel bundles exist between two switches, STP may block one of the bundles to prevent switching loops. When STP blocks one of the redundant links, it blocks the entire EtherChannel. So this blocks all the ports belonging to that EtherChannel link. Where there is only one EtherChannel link, all physical links in the EtherChannel are active because STP sees only one logical link. Okay? Next would be EtherChannel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. So therefore, a spanning tree recalculation is not required. Assuming at least one physical link is present, the EtherChannel remains functional, even if its overall throughput decreases because of a lost link within the EtherChannel. Implementation restrictions. EtherChannel has certain implementation restrictions, including the following. Interface types cannot be mixed. For example, Fast Ethernet and Gigabit Ethernet cannot be mixed within a single EtherChannel. Currently, each EtherChannel can consist of up to 8 compatibly configured Ethernet ports. EtherChannel provides a full duplex bandwidth up to 800 Mbps for Fast EtherChannel or 8 Gbps for Gigabit EtherChannel between one switch and another switch or hosts. The Catalyst 2960 Layer 2 switch currently supports up to 6 EtherChannels. However, as new IOSs are developed and platforms change, some cards and platforms may support increased number of ports within an EtherChannel link, as well as support an increased number of Gigabit EtherChannel. So the individual EtherChannel group member port configuration must be consistent on both devices. So if the physical ports of one side are configured as trunks, the physical ports on the other side must also be configured as trunks within the same native VLAN. Additionally, all ports in its EtherChannel link must be configured as layer 2 ports. Each EtherChannel has a logical port channel interface as shown here in the figure. A configuration applied to the port channel interface affects all physical interfaces that are assigned to that interface. AutoNegotiation Protocol. EtherChannels can be formed through negotiation using one of two protocols. You've got the Port Aggregation Protocol, or PAGP, or they call it PAGP, or the Link Aggregation Control Protocol, or LACP. These protocols allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. So take note that it is also possible to configure a static or unconditional EtherChannel without PAGP, PAGP, or LACP. Let's talk about the PAGP operation. So pronounced as PAGP, is a Cisco proprietary protocol that aids in the automatic creation of EtherChannel links. So when an EtherChannel link is configured using PAGP, PAGP packets are sent between EtherChannel capable ports to negotiate the forming of a channel. When PAGP or PAGP identifies matched Ethernet links, it groups the links into an EtherChannel. The EtherChannel is then added to the spanning tree as a single port. When enabled, PAGP also manages the EtherChannel. PAGP packets are sent every 30 seconds. PAGP checks for configuration consistency and manages link additions and failures between two switches. It ensures that when an Ether channel is created, all ports have the same type of configuration. So note that in EtherChannel, it is mandatory that all ports have the same speed, duplex settings, and VLAN information. Any port modification after the creation of the channel also changes all other channel ports. PAGP helps create the EtherChannel link by detecting the configuration of each side and ensuring that links are compatible so that the EtherChannel link can be enabled when needed. So the modes for PAGP are as follows. So first, you'll have on. Okay, so this mode forces the interface to channel without PAGP. Interfaces configured in the on mode do not exchange PAGP packets. So the next one is desirable. This PAGP mode places an interface in an active negotiating state in which the interface initiates negotiations with other interfaces by sending PAGP packets. The third one is PAGP Auto. This PAGP mode places an interface in a passive negotiating state in which the interface responds to the PAGP packets that is received but does not initiate PAGP negotiation. So the mode does not or must be compatible on its side. If one side is configured to be in auto mode, it is placed in a passive state, waiting for the other side to initiate the EtherChannel negotiation. If the other side is also set to auto, the negotiation never starts and the EtherChannel does not form. If all modes are disabled by using the no command, or if no mode is configured, then the EtherChannel is disabled. The on mode manually places the interface in an EtherChannel without any negotiation. It works only if the other side is also set to on. So if the other side is set to negotiate, okay, through PAGP, no EtherChannel forms because the side that is set to on mode does not negotiate. So no negotiation between the two switches means there is no checking to make sure that all the links in the EtherChannel are terminating on the other side, or that there is a PAGP compatibility on the other switch. PAGP mode setting example. Now consider the two switches here in the figure. You've got S1 and S2. And we will be employing PAGP between the switches. Okay? So whether S1 and S2 establish an EtherChannel using PAGP depends on the mode settings on each side of the channel. Okay? Now the table here shows the various combinations of PAGP modes on switch 1 and switch 2 and the resulting channel establishment outcomes. So if we set S1 and S2 on, there is a channel establishment. If we set S1 to on and S2 to desirable or auto, there is no EtherChannel establishment. So setting S1 and S2 to both desirable would yield to an EtherChannel establishment. Okay, so desirable auto or auto desirable on both sides, switch 1 and switch 2, would yield to an EtherChannel. But setting both S1 and S2 on auto will not establish an EtherChannel. LACP operation. LACP is part of the IEEE specification 802.3 AD that allows several physical ports to be bundled to form a single logical link. LACP allows a switch to negotiate an automatic bundle by sending LACP packets to the other switch. It performs a function similar to PAGP with Cisco EtherChannel. Because LACP is an IEEE standard, it can be used to facilitate EtherChannel in a multi-vendor environments. On Cisco devices, both protocols are supported. Take note that LACP was originally defined as IEEE 802.3AD. However, LACP is now defined in the newer IEEE 802.1AX standard for local and metropolitan area networks. LACP provides the same negotiation benefits as PAGP. LACP helps create the EtherChannel link by detecting the configuration on its side and making sure that they are compatible so that the EtherChannel link can be enabled when needed. So the modes for LACP are as follows. You've got on. This mode forces the interface to channel without LACP. Interfaces configured in the on mode do not exchange LACP packets. Okay, so the next one is LACP active. This LACP mode places a port in an active negotiating state. In this state, the port initiates negotiations with other ports by sending LACP packets. Next would be LACP passive. This LACP mode places a port in a passive negotiating state. In this state, the port responds to LACP packets that it receives but does not initiate an LACP packet negotiation. Just as with PAGP, modes must be compatible on both sides of the EtherChannel links to form. The on mode is repeated because it creates the EtherChannel configuration unconditionally without PAGP or LACP dynamic negotiation. So LACP allows for 8 active links and also 8 standby links. A standby link will become active should one of the current active links fail. LACP mode setting example. So consider again two switches here, S1 and S2. So this time, we will be employing LACP or LACP between the two switches. So whether S1 and S2 establish an EtherChannel using LACP depends on the mode settings on each side of the channel. So the table here shows various combinations of LACP modes on switch 1 and switch 2 and the resulting channel establishment outcome. So if we set both sides to on, there is a channel establishment. Okay? On, active or passive, there is no channel establishment. Same thing with setting switch 1 and switch 2, both on passive. So it will give you an LACP establishment or EtherChannel when we combined active and active on both switches. Or it could be active and passive or passive and inactive respectively. Okay? Configure EtherChannel. Let's have the configuration guidelines. Now that you know what EtherChannel is, this topic explains how to configure it. The following guidelines and restrictions are useful for configuring EtherChannel. Let's start with EtherChannel support. All Ethernet interfaces must support EtherChannel with no requirement that interfaces be physically contiguous. The next one would be speed and duplex. Configure all interfaces in an EtherChannel to operate the same speed and in the same duplex mode. VLAN mismatch. All interfaces in the EtherChannel bundle should be assigned to the same VLANs or be configured as a trunk. Range of VLANs. An EtherChannel supports the same allowed range of VLANs on all the interfaces in a trunking Ether channel. So if the allowed range of the VLANs is not the same, the interfaces do not form an Ether channel, even when they are set to auto or desirable mode. So the figure here shows a configuration that would allow an Ether channel to form between switch 1 and switch 2. Okay, so if you will see here, the switch 1 configuration, speed is set to 1 Gbps, duplex set to full, and it is on VLAN 10. So we should have an identical configuration on switch 2 so that an Ether channel will be formed. Okay, so with the settings here, an Ether channel is formed when configuration settings match on both switches. In the next figure, S1 ports are configured as half duplex. Therefore, an Ether channel will not form between switch 1 and switch 2. An Ether channel is not formed when the configuration settings are different on each switch. If these settings must be changed, configure them in port channel interface configuration mode. Any configuration that is applied to the port channel interface also affects individual interfaces. However, configurations that are applied to individual interfaces do not affect the port channel interface. Therefore, making configuration changes to an interface that is part of an Ether channel link may cause interface compatibility issues. So the port channel can be configured in access mode, trunk mode, most common, or on routed mode. LACP configuration example. Ether channel is disabled by default and must be configured. The topology here will be used to demonstrate an Ether channel configuration example using LACP. So configuring an Ether channel with LACP requires the following 3 steps. So first, step 1, specify the interfaces that compose the Ether channel group using the interface range interface global configuration mode command. The range keyword allows you to select several interfaces and configure them all together. Okay? Step 2, create the port channel interface with the channel group identifier mode active command in interface range configuration mode. The identifier specifies a channel group number. The mode active keywords identify this as an LACP Ether channel configuration. So step 3 is we need to change the layer 2 settings on the port channel interface. Enter port channel interface configuration mode using the interface port channel command. So followed by the interface identifier. Now in this example, S1 is configured with an LACP Ether channel. So the port channel is configured as trunk, okay, with the allowed VLANs specified here. So something like switch port trunk allowed VLAN 1, 2, and 20. Verify and troubleshoot Ether channel. As always, when you configure devices in your network, you must verify your configuration. So if there are problems, you will also need to be able to troubleshoot and fix them. So there are a number of commands to verify an Ether channel configuration. So let's start with show interfaces port channel. So the show interface port channel command displays the general status of the port channel interface. So in the figure, the port channel 1 interface is up. Okay? So this is port channel 1 combining FA01 and FA02 of both switches. So the next command that you can use to verify and troubleshoot Ether channel is to use the show Ether channel summary. Okay? When several port channel interfaces are configured on the same device, we use the show EtherChannel summary command to display one line of information per port channel. Okay? Now in here, in the output, the switch has one EtherChannel configured. Group 1 uses LACP. Alright? So the interface bundle consists of FA01 and FA02 interfaces going back to our topology here. Alright? Okay. Now the group is a layer 2 Ether channel and it is in use as indicated by the letters SU, alright, next to the port channel number. Alright, so the third command is the show EtherChannel port channel command. Okay, so which displays information about the specific port channel interface. Okay, now we use this show EtherChannel port channel command to display information about the specific port channel interface as shown here in the output. So in the example, port channel 1 interface, okay, consists of two physical interfaces, FA01, okay, and FA02. It uses an LACP, okay, in the active mode. It is properly connected to another switch with a compatible configuration. So which is why the port channel is said to be in use. Alright? Okay, so the next one would be show interfaces EtherChannel command. On any physical interface member of an EtherChannel bundle, the show interfaces EtherChannel command can provide information about the role of the interface in the EtherChannel as shown in the output. Okay, now the interface Fast Ethernet 01 is part of the EtherChannel bundle. Okay, so the protocol for this EtherChannel is LACP. Okay, so protocol is LACP there. Common issues with EtherChannel configurations. All interfaces within an EtherChannel must have the same configuration of speed and duplex mode, native and allowed VLANs on trunks, and access VLANs on access ports. Ensuring this configuration will significantly reduce network problems related to EtherChannel. So common EtherChannel issues includes the following. So first, assigned ports in the EtherChannel are not part of the same VLAN or not configured as trunks. So ports with different native VLANs cannot form an EtherChannel. Okay. Next, trunking was configured on some of the ports that make up the EtherChannel, but not all of them. It is not recommended that you configure trunking mode on individual ports that make up the EtherChannel. So when configuring a trunk on the EtherChannel, verify the trunking mode on the EtherChannel. If the allowed range of VLANs is not the same, the ports do not form an EtherChannel even when PAGP is set to auto or desirable mode. So the dynamic negotiation option for PAGP and LACP are not compatibly configured on both ends of the EtherChannel. So take note that it is easy to confuse PAGP or LACP with DTP because they are all protocols used to automate behavior on trunk links. PAGP and LACP are used for link aggregation or EtherChannel. DTP is used for automating the creation of the trunk links. So when an EtherChannel trunk is configured, typically the EtherChannel PAGP or LACP is configured first, then DTP. Troubleshoot EtherChannel example. In the figure, interfaces FA01 and FA02 on switch 1 and switch 2 are connected with an EtherChannel. So if you have seen the symbol, it means it is an EtherChannel. However, the EtherChannel is not operational on this topology. Okay? So to troubleshoot the EtherChannel, so first, we need to view the EtherChannel summary information. So we could do that via show EtherChannel summary command, which indicates that the EtherChannel here is down. All right. Okay, so step 2, view port channel configuration. So you can use the show run, or you could have the shorthand notation show run begin interface port channel. Okay, so it presents a more detailed output that indicates that there are incompatible PAGP modes configured on switch 1, okay, and switch 2 here. Okay, you've got on there, and then in here, these are desirable. All right. So the next thing is you need to correct the misconfiguration. So to correct the issue, the PAGP mode on the EtherChannel is changed to desirable. Okay, so it has changed to desirable from the previous. Okay, let's go back to the previous one. It is set to on. So we are going to correct this problem. Okay, so take note that EtherChannel and SDP must be interoperate. Okay, for this reason, the order in which EtherChannel related commands are entered is important, which is why you see interface port channel 1 removed and then re-added with the channel group command as opposed to directly changed. Okay, so if one tries to change the configuration directly, STP errors cause the associated ports to go into a blocking or error disabled state. Okay, and finally, you need to verify EtherChannel if it is operational. So the EtherChannel is now active here. Okay, so it is now active and verified by the output show EtherChannel summary command. All right. So that's the end of this video lecture. Hope you learned something new on this video. Have a great day. Thank you for watching and listening.